In this video, I'll be talking about estimation, graphs, and mathematical models. It says here, estimation is the process of arriving at an approximate answer to a question. Computations can be estimated by using rounding that results in simplified arithmetic. Now, I just want to make one note at the top, or to start here. In my own opinion, estimation is something where there's not just one way to do it. And so, especially in the problems that you'll see eventually on the test or quiz, I'll try to make those as clear as possible. But there is some variation in how you round when you estimate. The bottom line is we tend to do what's easiest for us to get a quick calculation. Now, I've given you the process of rounding whole numbers for those of you that are a little rusty with that, but let's go ahead and see how it works in example 1. If you aren't very good at rounding numbers, you can go online and find all sorts of materials on rounding whole numbers. So if you need to practice, you can certainly do that. But we're just going to assume that you know how to do it, or you can read the directions here and hopefully that'll help. So the world population is about 7,346,235,000. Round the world population to the nearest 100,000. So first of all, you got to know where the 100,000s place is. That's right here. And you look to the right and you see a 3. Since that number is less than 5, we leave the 2 alone. If it had been 5 or larger, we would have rounded up. And so our answer here is going to be 7,346,200,000. On example 2, it says, you and a friend ate lunch at Ye Olde Cafe. The check for the meal showed soup for $3.40. And I'm not going to read all the rest of it, but you have these prices for these different items. It says in part A, round the cost of each item to the nearest dollar and obtain an estimate for the food bill. All right, so I'm going to go ahead and write down all the prices. Really, that's all that matters here is we want to get a total of the prices. So we have $3.40, $2.25, $5.60, $5.40, $3.40, $2.85, and $3.95. And notice it says round each of these to the nearest dollar to obtain an estimate. So $3.40 rounds to 3, $2.25 rounds to 2, $5.60 rounds to 6, $5.40 rounds to 5, $3.40 rounds to 3, $2.85 rounds to 3, and $3.95 rounds to 4. So if you add these numbers up, which hopefully you can do in your head, you get 26. So in part B, it says the total, actually let me write down that answer here. So $26 is our estimate. The total bill before tax was given as $29.85. Is this amount reasonable? Well, based on what we got, I would say it's a little bit high. So I'd say no. In fact, if you look at the numbers, well, think about this. When you're rounding to the nearest dollar, like if it was at $3.50, you'd round to 4. The most you could be off is 50 cents. And there's 7 calculations here. So if we rounded every one of them up 50 cents, 7 times 50, that would be $3.50. And if you look at the actual rounding that we did, that's not even close to the case. In about half the cases, we rounded down. In about half the cases, we rounded up. And we never rounded as much as 50 cents. So in any case, I would say that's high. All right, let's move on to the next slide. Oh, by the way, the actual amount was $26.85. All right, so on number 2, it says graphs and estimation. Circle graphs or pie charts show how a whole quantity is divided into parts and used to compare parts to a whole. So I'll just give you an example here. So here is a graph, or I should say a circle graph or a pie chart where we have freshmen, sophomore, juniors, and seniors, and you can see what percentage of the class each one of these is. And so that would be a good example of a circle graph or pie chart. Bar graphs are convenient for comparing some measurable attribute or quality of various items. So I've put up an example here. This is the number of students having a part-time job, and these are basically the students I was referring to in the circle chart or the circle graph. And you can see that basically, the seniors are going to have the most students with part-time jobs. And you can see as you get down to the freshmen, those are the ones that have where there's the least number of students with a part-time job, which makes sense. So let's look at, and by the way, bar graphs and line graphs, I think sometimes you could go either way with those. It really is kind of a personal preference. Although line graphs, as it says here, are often used to illustrate trends over time, some measure of time, such as months or years, frequently appears on the horizontal axis. Amounts are generally listed on the vertical axis or segments. All right, so in fact, if you look at the problem we're about to do, that would be an example of a line graph. All right, so let's go ahead and I would actually, I would say in this section, maybe until we get to the end, a lot of the work is stuff that you probably already know as far as reading graphs and being able to answer questions. If this is an area of weakness, then you just get better by doing it and reading more graphs and practicing. So that's what I would encourage you to do. That's why we have homework. All right, so let's look at A here. It says find an estimate for the percentage of college students who smoke cigarettes in 2010. Well, one of the things you've got to watch out for, and you might even want to put in the numbers here, notice here you're going from 1982 to 1990. So in fact, that's 8 years. And so these middle marks are basically indicating a 4-year period. We're at this mark, we're actually at 1986. And here, this would be 1994. And so in 2010, that would actually be right here. And you can see that you can just kind of go across to here, and you can see that that's about 18%. Whoops. In part B, it says, in which 4-year period did the percentage of college students who smoked cigarettes decrease at the greatest rate or the fastest rate? So you can certainly see it's going down here. And notice that is a 4-year period, and that's what we're looking at is 4-year periods, and it's decreasing here as well. Here's another place where it's decreasing. However, wouldn't you say that that's where we have the greatest decrease? And so that's in the years 2002 through 2006. All right, let me erase what I did on the graph here, clean this up a little bit. All right, so in C it says, in which year did 30% of college students smoke cigarettes? Well, 30% is right here, whoops, right here, and if you go across, that would be in 1998. All right, so hopefully you did well on that one. Let's move on to the next slide. This will actually be our last slide. And this is called mathematical modeling, which is actually a very important concept. In this course, we're just doing some real basic mathematical modeling. But in reality, huge corporations these days, they make lots of important decisions, and they don't want to base those decisions on hunches or best guesses. And so they collect lots of data. They actually hire people and pay them really well to collect data and look for trends and try to capture all the things that go on within their business in terms of the statistics or the data. And then they end up, writing equations and looking at graphs. And they use all this to make predictions and to make decisions. And so, anyway, all to say, if you find this interesting, you might eventually want to take a statistics course. And if you really enjoyed that, there's a lot of great opportunities for people that want to do mathematical modeling. All right, let's look at this graph here. Let's see, the process of finding formulas to describe real world phenomena or situations is called mathematical modeling. Again, we're starting real basic here. So it says this chart gives us the average. This is where I'm reading here. The average cost of tuition and fees at private four-year U.S. colleges. So in A, it says estimate the yearly increase in tuition and fees, round to the nearest dollar. So we're looking for the yearly increase in fees. So maybe the price is going up $1,000 per year, for example. So this is what we call a rate. We have two measures. We have a certain amount of money per year. So money and years. And so let me go ahead and do my work up here. So what we're going to look at over this whole period of time, what the graph is telling us, notice we're going from $15,518. This is tuition and fees per year, and it goes up to $33,480 over this period of time. So it's going to be the change in tuition divided by the change in time, which is in years. And that's how we're going to find the change in the tuition per year. So if we subtract the largest minus the smallest value, and really we're just looking at these two numbers here, basically what happened from 2000 to 2016, so that'll tell us how much tuition increased over that period of time. And in the denominator, we're going to subtract the number of years that passed. So this has been a 16-year period. So I'm going to go ahead and subtract these numbers. You get 17,962 over 16. And if you simplify that, basically I'm just going to divide by 16. You get $1,122.63 per 1 year or per year. Now it says estimate the yearly increase in tuition and fees round to the nearest dollar. And so that would be about $1,123 per year. That's on average how much the price was going up each year. Now in part B it says write a mathematical model that estimates the average cost of tuition and fees, which we're calling T, at private four-year colleges for the school year ending X years after 2000. All right, so T is going to be our tuition. Now, in 2000, the starting amount for tuition was $15,518. Now, remember, it's going up $1,123 per year. So think about how you would write that if X is the number of years after 2000. So if X is 1, you would add 1123 once. If X is 2, so 2 years later, you would add 1123 twice. So the equation should be 15,518 plus 1123 times X. And so this is a model to help us make predictions for the future. Now in C it says use the mathematical model to project the average cost of tuition and fees at private four-year colleges for the school year ending in 2020. Well, 2020 is 20 years after the year 2000. Remember, our data starts in 2000. That's our starting point. So in 2020, we're 20 years later, and we're no longer, notice we're off the grid here. This is 4 years after our last amount. So I'm gonna write the formula. I keep forgetting to highlight those. And I'm going to replace x with 20. And so you get $37,978. Now, I don't know how accurate that is, but I know that's a lot of money. And in fact, it's quite expensive to go to college these days. But it's still well worth it. That's it for this video.